Yes, in this example, we have to obtain the half range cosine series for the function f of x is equal to 4 minus x square in the interval 0 less than x less than 2. Read the question carefully. It is asked to find the half range cosine series. We have to find half range cosine series for the given function in the interval 0 to 2. Here the interval is arbitrary. It is from 0 to 2. It is in the form 0 to L. Now we know that half range cosine series in the interval 0 to L is given by the formula f of x is a0 upon 2 plus summation n into cos n pi x by L, where a0 is given by the formula 2 upon L into integration 0 to L f of x dx, and n is given by the formula 2 by L into integration 0 to L f of x into cos n pi x by L dx. Now in this question f of x is 4 minus x square and the interval is 0 to 2. If you compare that interval, arbitrary interval 0 to 2 with this 0 to L, here L is 2. So in this problem L is 2. Remember that whenever it is asked to find half range sine series or half range cosine series, we do not check whether the function is even or odd. We don't have to check the function is even or odd. Directly using the respective formulas, we'll find the value of a0 and an. Now to find a0, we have this formula 2 upon L. So substituting the respective value, L is 2, 0 to 2, integration with limit 0 to 2, f of x is 4 minus x square dx. So see, we are using this formula to find a0. We are substituting the respective value of L as 2 and f of x as 4 minus x square. If we integrate this, remember integration of k dx is k into x, whereas integration of x square dx using the formula x raised to n dx, we know integration x raised to n dx is x raised to n plus 1 upon n plus 1. So we apply this formula, our a0 is going to be, that 2 gets cancelled, integration of 4 dx becomes 4x, integration of x square becomes x cube by 3, and the limits are 0 to 2. We'll substitute the respective values. So in place of x, if you put the upper limit 2, it will be 4 into 2 minus, in place of x we write 2, it will be 2 cube upon 3, the upper limit, minus the lower limit. If you put the lower limit 0 in place of x, 4 into 0 is 0, 0 cube is 0. So this comes out to be 8 minus 8 by 3. We find this value, so it will be 24 minus 8, that will be 16 upon 3. Okay, a0. So this value you can find on calci also directly. We have found out a0, and now to find an. See, the formula to find an we know is 2 upon L integration 0 to L of x into cos of n pi x upon L dx. We know in our case L is 2, limits of the integration are 0 to 2, f of x is 4 minus x square into this cos of n pi x upon 2 dx. Now we'll solve the integration. This 2 by 2 is 1. See, to solve the integration, we are going to use the formula integration u v dx is u into v1 minus u dash into v2 plus u double dash into v3 minus u triple dash into v4 plus dot dot. The formula that we are going to use according to the order of islate or light. We know that 4 minus x square is the algebraic function, cos n pi x upon 2 is a trigonometric function. So according to this order, 4 minus x square comes first. We are going to take u as 4 minus x square. So therefore u dash, derivative of 4 minus x square, derivative of 4 will be 0, derivative of minus x square is minus 2x. U double dash, derivative of minus 2x we know is minus 2. U triple dash, derivative of minus 2 is 0. We know dash represents derivative. U dash is the derivative of u. U double dash is derivative of u dash. U triple dash is the derivative of u double dash. Then here v is cos n pi x upon 2. V1. V1 is the integration of V. Remember, in general, we know integration of cos AX dx is sin AX upon A. So integration of cos n pi x by 2 will be sin n pi x upon 2 divided by n pi by 2. So it comes out to be 2 upon n pi into sine of n pi x upon 2. That is our V1. Once you get V1, we'll find V2. Again, I'll write V1. V1 was 2 upon n pi into sine n pi x upon 2. V2 will be integration of V1. Remember, suffix represents integration. V2 is the integration of V1. Now, so it will be this 2 upon n pi being constant, we'll take it outside the integration. It will be integration of sine n pi x upon 2 dx. Remember the formula, integration of sine ax dx is minus cos ax upon a. When we integrate this term, this 2 upon n pi is as it is outside the integration. Integration of sine becomes minus cos n pi x upon 2 divided by n pi by 2. This will be minus 2 upon n pi cos n pi x by 2 minus 4 upon n square pi square cos n pi x upon 2. This is our V2. We'll also have to find V3. We know term still. We know that term still U double dash are existing. So we need term still V3. We don't have to find V4 because U triple dash is 0. So V3 is going to be the integration of V2. That's minus 4 upon n square pi square is constant. We'll take it outside the integration. It will be integration of cos n pi x. Integration of cos n pi x by 2. This minus 4 upon n square pi square as it is. Integration of cos n pi x by 2 is sin n pi x upon 2 divided by n pi by 2. We know integration of cos ax is sin x upon a. This n pi by 2 will, again the reciprocal of that will get multiplied. So minus 4 upon n square pi square into 2 upon n pi into sin n pi x upon 2 becomes minus 8 upon n cube pi cube sin n pi x by 2. So see, V was cos n pi x by 2. We got V1 as 2 upon n pi into sin n pi x by 2. V2, we have got V2 as this term minus 4 upon n square pi square cos n pi x by 2, and V3 we have got it as minus 8 upon n cube pi cube sin n pi x by 2. See, in exam you may skip these steps, but I am showing this in details so that you will understand it properly. So while you are practicing for the first time, you may write all these steps in details, but after practice, when you are confident, you may skip these steps. Now, so see, our aim is to find an. So see that 2 by L will be 2 by 2, integration will be 0 to 2. It is 4 minus x square into cos of n pi x upon 2 dx. This is the term that we are solving. You see, this 2 upon 2 becomes 1. It is u into v1. U is 4 minus x square. V1 is 2 upon n pi into cos of n pi x upon 2. Is u into v1 minus u dash. U dash is minus 2x into v2. V2 is minus 4 upon n square pi square into sine of n pi x upon 2. So it is u into v1 minus u dash into v2 plus u double dash. U double dash is minus 2 into v2 is minus 8 upon n cube pi cube cos of n pi x upon 2. So yes, I have made a mistake here. It should be, yes, I have made a mistake here. It was sine here. Yes. So integration of v is cos. So integration of cos v is going to be sine n pi x upon 2. Okay, and integration of the sine is going to be cos. Okay, so here I have made a mistake. It should be cos here. Okay, so cos n pi x by 2, and this term here is going to be sine. Integration of cos is going to be sine. Yes. So see, it is u into v1 minus u dash into v2 plus u double dash into v3. U triple dash is 0. Derivative of minus 2 is 0. And this entire term is within the limit 0 to 2. If you put the upper limit now, first, wherever there is x, in place of x, we are going to write the upper limit 2. See, when we put the upper limit 2 in place of x, this will be 4 minus 2 square. 4 minus 4 will be 0. 0 into this whole bracket is going to be 0, remember. Again, when you put x is 2 here, 2 gets cancelled, this becomes sine n pi. Sine n pi is also 0. This bracket is 0, this also is 0. 0 into 0 is going to become 0. Here, if you put x is 2, 2 into 2 will be 4, and 4 into 4 will become 8 here. And if I put 2 here, 2 gets cancelled, this becomes cos n pi. If I put 2 here, this 2 gets cancelled, it becomes sin n pi. But before I substitute the limits, I just simplify this. To see this, you may write it as 4 minus x square into 2 upon n pi into sin n pi x upon 2. Minus into minus is plus, plus into minus is minus, 4 into 2 is 8, so 8x into cos of n pi x upon 2. This minus into minus will be plus, plus into plus is plus, 8 into 2 is 16, 16 upon n cube pi cube sin n pi x upon 2 within the limit 0 to 2. Now, see, if you put the upper limit 2 in place of x, if I put upper limit 2 in place of x, this will be 4 minus 4, which is 0. This will, if I put 2 here, this 2 gets cancelled, becomes sin n pi is 0. So 0 into 0, entire term is going to be 0 here. When you put the upper limit 2 in place of x, if I put 2 in place of x, 8 into 2 will be 16. So minus 16 into cos of minus 16 into cos of n pi. If you put x is 2, this 2 gets cancelled, it becomes only cos n pi. Plus 16 upon n cube pi cube. If you put x is 2 here, 2 gets cancelled, this becomes sin n pi, which we know is going to become 0. So we get this first bracket when we put the upper limit pi in place of, upper limit 2 in place of x. Now, if I put the lower limit 0 in place of x, this will be 4 minus 0, which is 4 into 2 upon n pi. If you put x is 0 here, it will be sine of 0, which again going to become 0. So if I put x is 0, this will be 0 here, and so this becomes sine 0, which is 0. Next term, this will be 8 into 0 into cos of 0. If I put x is 0 here in this second term, 8 into 0 is 0, 0 into cos is going to become 0. And here it will be 16 upon n cube pi cube sine of 0. If you put x is 0 here, this is going to be sine 0 term, sine 0 is going to be 0. So 16 upon n cube pi cube into sine 0 is going to become 0. Remember, we know that cos n pi is minus 1 raised to n. So if you put cos n pi is minus 1 raised to n, this is going to be minus 16 into minus 1 raised to n. Sin n pi term will become 0. The sin 0 term will become 0. Sin 0 term will become 0. We know sin n pi is 0. For any integer value of n, sin n pi is 0. Sin 0 is 0. Two terms also become 0. So only one term is going to exist. This minus 16 cos n pi. Okay, and here, okay, I think I have missed this term. This was upon n square pi square term was there. Upon n square pi square term was there, which I have missed. Totally that term will be there. Okay, so it is going to be minus 16 upon n square pi square into cos n pi. Correct? So see this n square pi square I had missed, I had not written in this step. It will be that minus into minus is plus, plus into minus is minus, 4 into 2 is 8 into this x, 8x cos n pi x by 2 upon n square pi square is going to be there upon n square pi square. So now if you substitute these values, we'll get n is equal to, so see, only this term is going to exist. Minus 16 upon cos n pi upon n square pi square is going to exist. All remaining term becomes 0. So n is equal to minus 16 upon n square pi square into minus 1 raised to n. You can keep this term as it is, or you may write this as 16 into minus 1 raised to n plus 1 upon n square pi square. It is minus into minus 1 raised to n. You can keep it as it is, or you may write it as minus into minus 1 raised to n. You can write it as minus 1 raised to n plus 1. So we have got our n. Now we know that half range cosine series, half range cosine series for f of x in the interval 0 comma L is given by the formula f of x is equal to, you can write as a0 divided by 2, or you may write it as 1 upon 2 into a0, 1 upon 2 into a0 plus summation n is 1 to infinity n into cos of n pi x upon L. So see, in this problem, f of x was 4 minus x square is equal to this 1 upon 2 into a0. So see, the value of a0 that we have found out was 16 by 3. So 16 by 3 plus summation n is 1 to infinity as it is. N, the value of n we have found out is 16 into minus 1 raised to n plus 1 upon n square pi square into this cos of n pi x upon, in place of L we'll put 2. In this question we know L is 2. So this becomes 8 by 3, this half into 16 by 3. This a0 by 2 you can write as half into a0. It becomes 8 by 3 plus, you may take 16 upon pi square common. See, this term you may keep it as it is, or you may take the constant term 16 upon pi square common from the summation sign, outside the summation sign. It is minus 1 raised to n plus 1 upon n square into cos n pi x upon 2 as our answer. So this is the required half range Fourier cosine series. So this is the required half range Fourier cosine series.